Hello, we are Group 2, and today we are presenting our project for meetings 14 and 15. My name is Rakha, and I'm here with my teammates Hafizh, Atallah, and Yeremia. Our project is titled Virtual Machine for Multi-User Security Practice. The main objective is to build a secure Ubuntu-based environment and demonstrate how to manage users and permissions effectively. In this video, we will walk you through the entire process, from VM installation to advanced security analysis. We will show how a multi-user system operates in a real-world scenario. The core of our scenario involves setting up different access levels for admin, staff, and guest roles. This ensures that sensitive data is protected using the principle of least privilege. Let's get started.
So, before we dive into the installation, let's look at the core concepts. A virtual machine, or VM, is a software-based simulation of a physical computer. It allows us to run the Ubuntu operating system in an isolated environment on our host PC. This is essential for security practice because it provides a sandbox where we can test security configurations and simulate attacks without risking our actual hardware. The foundation of Linux security is the multi-user system. In this environment, every file and directory has specific permissions. These are divided into three types: read for R, and then write for W, and then execute for X. By managing these, we can control exactly what the user can see or modify. A critical security standards with our following is the principle of least privilege. This means giving a user only the minimum levels of access or permissions needed to perform their job functions. For example, a staff member might read a document, but a guest should not even be able to open a folder. This minimizes the attack surface and protects sensitive files from accidental intentional harms. Okay, so we will move to the number 3, where we have to make the VM installation. So here on the Oracle VirtualBox Manager, we go to the new option here, and then click it. Then we have to name the virtual machine. Let's say the name is CSOP 321, and then it was saved in this folder on the C drive. And then for the ISO image, we have to choose the Ubuntu because we want to use Ubuntu here. And then we just uncheck this because we don't want to log into the next step, and all of it is already correct. The OS is Linux, and then OS distribution is Ubuntu 64-bit. We just go to next. And then for the base memory, let's say we'll just use 4 megabytes. And then for the numbers of CPU, let's use 6 numbers of CPUs. And for the disk size, let's go with 10 gigabytes, around 10. Okay. And click next. And then this is all the summary or the report that you have been made. So the name is here, CSOP1321, and then the VM folder is here on C drive. ISO image is here, and then blah blah blah. We just finish this step, and we're done with number 3.
After we done setting up the virtual machine, now we will start the virtual machine. In this selection, we will select install Ubuntu. After we done booting up, it will show a installer interface. Now I will click install Ubuntu. We will stick with English as the default language and English as the default keyboard layout. Continue. I will select minimal installation to speed up the installation process. I will unclick this one to make sure it will load without updating the next time we log in. Because this is a virtual machine, we will select erase and install Ubuntu. We click install now. will show this and we will click continue. And it will automatically ensure our correct local time. And since we in Western Indonesian time, it chose correctly Jakarta as the base. Now this is the important part of this section. We will now create identity. I will create the initial administrator account using my name, which is admin underscore Hafizh. We have error. The computer name must contain letters, digits, hyphens, and dots. So we must make this simpler. Sorry, this is the computer owner name. I will select sysop project. And this is the administrator account, which is my name admin underscore Hafizh. Sorry. Only lowercase. Okay, so I will select secure password. Let's see, one. Now I will select. This is the preference, but my preference is login automatically. We continue. And we will wait the installation. This will take quite a long time, so we will wait. Once the installation completes, it will automatically restart the virtual machine. Now, as you can see, we have successfully reached the login screen, and we can now access our new secure Ubuntu environment. So let's try. And now, as you can see, we can log in into Ubuntu. Now that the installation is complete, you can see that the Ubuntu desktop is running normally. See, and our environment is ready for security configuration. Now we can access our terminal. This is where we perform our administrative tasks. In Linux, the command line is the most powerful tool in managing security policies and user permissions. So I can run the command who am I, and it will show the current user in this session. And now I can run host name ctl to show the computer specifications, and you can see our operating system is Ubuntu with Linux kernel. So that's all for system readiness.
Okay, so now I will be creating an account for our group member. So first, let me create account for myself, Atallah, as a staff. First, we type add user. And then our account name. Okay, so now we'll be creating a new password. Let's see. Okay, so here we can type our name. Here I will just type Atallah. Then we will skip this for now. Yes. Okay, so the next account we will create for Rakha. Staff Rakha. And then type new password. Just type Rakha here. Yes. Then the last one is for Yeremia. User. So Yeremia as a guest here. Guest Yeremia. Create a password here. Yeremia. So now I will be switch the user using subscribe to verify each account is active or not. So first here is and first is my account Atallah, and use who am I. You can see here that the account is already active for staff Atallah. Let's move it to other account. Next one is staff Rakha. Who am I? You can see here the staff Rakha also already activated. Last one is for Yeremia. So, who am I? Okay, so the guest Yeremia is already activated also. So the account created is already successful. So now I will do the multi-user and permission configuration. So first I will create a formal group for our department using add group. Add group. Our group name here is the management department. Then next we need to assign each group member to the management department. So in this department we will assign only staff here. So first we add myself as staff. Modes AG management department staff Atallah, and then we will do the same for staff Rakha. Okay, after adding the members to the group, we need to create the shared resources in a directory. So we need to use make directory srv secure data. Let's say secure data. Data. Okay. And now for the core security implementation, I will use count management SRV secure
I think you need to add a space.
Oh yeah, sorry.
Okay.
Okay. To give our group ownership of this folder. Now I will use Muhamad tutorial SRV secure data. So these specific settings mean the admin and staff can read, write, and execute, but the guests and anyone else will be completely locked out. So by doing this, we are applying the principle of least privilege. We aren't just blocking the guests, we are ensuring that only users who need access to the management data files have them, effectively preventing internal data leaks and limiting the damage if a lower level account is compromised.
Log in.
Okay, now we are going to test using two accounts, that is staff and guest, whether I can access the data using the staff account and this guest account. So first, I'm going to log in using the staff account. Okay, now I have succeeded login as the staff using the staff account. Sorry. Now I'm going to try to access the data using the staff account. As we can see, I succeeded accessing the data using the staff account. Now I'm going to try to log in as the guest account and whether can I access the data or not using that guest account. Okay, so I'm going to log in now. Okay, I successfully logged in as guest Yeremia, or we can say the guest account. Now I'm going to try to access the secure data. As we can see, it is denied. So we can conclude that the staff is granted access to the secure data, and the guest account doesn't have an access to that secure data. Okay, so I think that's it for me. Yeah, thank you. Okay, through this setup, we have successfully prevented two major threats: unauthorized data access and privilege escalation. By isolating the guest user, we ensure that even if a guest account is compromised, the sensitive departmental data remains encrypted and inaccessible. It's important to note that the risk of incorrect configuration. If we had mistakenly used chmod 777, for example, the guest would have full control over the admin files. This over-permissioning is a leading cause of data breaches in real-world server environments. And while our current setup is strong, it has limitations. Standard Linux permissions can be rigid. For more complex environment, we would implement access control lists or ACLs for more granular control, sudo policies to limit administrative commands, and audit logs to track every single access attempt in real life. This enhancement would transform this basic setup into a production-grade secure system.
Okay, so in conclusion, we have successfully demonstrated the full life cycle of a secure multi-user environment, starting from the ground up with a clean OS installation and by setting up the system correctly from the first boot. And also, we ensure a stable foundation for all subsequent security layers.
As the administrator for this project, I learned that security is not just about passwords, but about verifying identities and maintaining clear system logs. This mirrors real-world server management, where administrative accountability is the first line of defense.
Through the configuration of group and directory permission, we applied the principle of least privilege in a practical way. We saw how essential it is to define roles, like staff, guests, admin, to ensure users only have access they truly need.
Finally, our testing proved that these configurations successfully prevent unauthorized access to sensitive data. This simulation is highly relevant to cloud and server environments where protecting shared resources is a daily necessity for cybersecurity professionals.